I begin. We all here probably saw the footage of the collapse of the Arecibo radio telescope 2 months ago. There has been a lot of comment on how this was the final outcome of a process of decline over about 30 years from the 1990s onwards. Journalistic investigations on the cause of the collapse so far have focused on two narratives: instrumental life cycle on the one hand and changing economic support conditions on the other. They are not wrong, but they are contextualized from the wider forces that have transformed astronomical observation in the past 2 generations, and which tell us something about the viability of Cold War era observatories in a new environment that I call economic neoliberalism that we live in today. The first narrative of decline one encounters is of a technological life cycle. By this logic, telescopes like the one at Arecibo are almost living entities, destined to experience an early heyday and then gradual but inevitable decline, becoming increasingly obsolete and eventually superseded by a new next generation of instruments. The viability of the observatory site, as opposed to the observatory telescopes in it, in this narrative, is largely determined by the quality of observational conditions that it offers. The fate of Cold War observatories as institutions, rather than buildings or geographical sites, is not much further explored. A second narrative, let's call it microeconomic, says that the economic management itself was the leading destructive entity, kind of a transient catastrophe that could have been averted. In this second perspective, the implicit message is that it would have been possible to act differently and maintain a world-leading productive research facility indefinitely. Proponents of this model could, for example, point out that many of the world's most venerable observatories have centuries of continuous operation behind them. But observatories built after 1945 are an entirely different beast to what existed before. These original ones just referred above from before the 20th century were located near the seats of national power and formed part of a system in which astronomy was an integral part of nation-state formation. And though this era is gone, they maintain their disciplinary privileges and prestige. These observatories don't even do much observing directly anymore, but remain the seats of disciplinary power in astronomy, often even managing to absorb the practitioners of observation in wavelengths that only appeared after World War II. Early 20th century observatories followed a different logic of their own that I don't have much time to discuss here, dominated by private philanthropy, which still plays a considerable role in astronomy compared to other forms of physical research. But private philanthropy has long stopped being the dominant driver of the field, even though it may rise in dominance as the fortunes of the world's riches increasingly define other areas of cosmic exploration. The entities that we will focus on here date from after 1945, and as I discuss here, a majority of them stopped being viable around 1990, giving definite way to other models of astronomical observation, from which the word observatory is disappearing altogether, to be replaced by terms like facility or site of an infrastructure managing organization. To be clear, the disappearance of the Cold War era observatories is not because of intrinsic technical limitations, but because the sociopolitical environment of which they were part no longer exists, superseded by a much more economically driven form of organization. And in this new regime, it is hard for them to survive in the long term. Also, to be clear, this talk is not an accusation of our present economic form of organization or a call for return to earlier times, but rather a starting point to reflect on the wider sociopolitical forces that shape scientific research and how we must take them into consideration in our analysis of the internal developments of a field. This talk is ultimately about geopolitical power and economic forces on a global scale. While these two aspects are always present and are mutually reinforcing, we see the two distinct regimes in which their explicit dominance was different. During the Cold War era, explicit geopolitical considerations in scientific research trumped scientific ones. After 1990, the situation was inverted. That is not to say that one makes the other disappear, but in policy considerations and narratives, the recessive one of them becomes implicit while the other turns explicit. When hearing this talk, some of you will complain that I undervalue the importance of the growing scales of scientific research, which is generally seen as the driver of the changes that I describe next. Other presentations today and tomorrow will focus on that aspect, which is clearly fundamental. But what I claim here is that many of the organizational changes that I describe are not alone explained by scaling effects, and in fact predate the moment when the scale of research demanded such forms of organization. Implicit throughout my talk is the claim that the organizational structures for large-scale research somewhat predated their actual necessity and were initially driven by geopolitical needs and domestic disciplinary politics. By 1990, the scale of research had well grown into this model and shown considerable successes, but it was still largely geopolitically driven. Then, around that decade, the division between research infrastructures and scientific users happened to align particularly well with a newer, predominantly economically driven view of large-scale research, and the separation of users and infrastructures was a universal economy-driven trend seen, for example, in transportation or electric grids. My reflections come from studying a vast environment for the past 4 years, which has experienced the pressures due to transformations in the global nature of scientific research. Together with Luisa Bonolis, we finished writing a book on the history of astronomy, astrophysics, and space research in West Germany in the second half of the 20th century. During the majority of the period that we studied, the Max Planck Society was the institution in charge of high-end fundamental research in Germany, growing to conduct more of cosmic research than the pre-existing observatories and the university system, even though the last one was also significantly expanding during the same period. Due to the uniquely federal nature of post-war Germany, there was no single unit conducting cosmic research in the Max Planck Society, but rather a conglomeration of distinct institutes, each with their own genealogies and scientific traditions, as well as their own regional, political, and industrial allies, which at different points jumped into cosmic research. As the second half of the 20th century progressed, one can see the increasing connection among the different research traditions, the increased coordination of their activities, and also a decisively growing weight of what one would call astronomical observation in comparison to other forms of cosmic research, such as plasma physics or cosmochemistry. All this while distinct institutes still depended on their original distinct intellectual strengths. Over the decades, the Max Planck Society expanded into almost all observable wavelengths and was also particularly strong in the new forms of multi-messenger astronomy, such as neutrinos and gravitational waves. Many aspects of these developments are uniquely German and uniquely Max Planck, as we explain in detail in our book. For this talk, however, I focus on those aspects where we see a general trend that reflects what was also happening elsewhere in astronomy. Central to this talk, we describe in our book a very distinctive transition in the organization of research that occurred in the 1990s, but with long roots in the 70s and 80s. Before this transition, there was a strong emphasis on developing national capabilities, that is, astronomical observatories for the German scientific community. In the later years, there was a shift towards multinational collaborations under a deliberate division of astronomical work between long-term research infrastructures and short-term scientific users. The central message of this talk is that this shift was not just due to the increasing scale of research, which obviously plays a role, but rather how astronomical work in each period reflected the dominant or underlying rationale for its existence. In the Cold War era, this was geopolitical considerations. In the second era, it was a more economicized understanding of scientific activities. When looking at the pre-1990s mode of scientific production, the emphasis was not just national ownership, but also vertical integration. In the first generation of expansion into new wavelengths, while sometimes the new observatories were de jure separate institutions, the economic and power relationships were unambiguous, a distinct Max Planck institute with a particular tradition in a specific wavelength, had built at the de facto owned a specific observatory or even astronomical satellite and controlled access to it. The predominant logic was still largely towards scientific autarky. International collaboration, of course, existed and since long had been a dominant factor in astronomical research. But the basis of this collaboration was considered to be strong, self-sufficient national institutions. Moreover, beyond their scientific tasks, it was evident that sociopolitical support of these expensive endeavors came also from national economic justifications. They were the showcases for projecting West German industry on a global scale, with recognized brands such as Krupp or Zeiss being involved in their construction. It is not that these industries were always drivers of these projects. They rather existed on a spectrum of interest that spanned from the regional support in fostering specific industries to their own drive towards keeping a foot in new technologies also relevant in adjacent fields such as telecommunications. West German policies of fostering exports and integration to world markets were overactive and effectively an unofficial second arm to pursue its international reintegration. International scientific collaboration in this era also fulfilled a similar supporting role to geopolitics. So it is not strange to find a strong link between economic and scientific justification for large-scale scientific projects in this period, including those in the cosmic sciences. But these were also a sublimation of geopolitical ambition through international economic and scientific activities. At the same time, even in West Germany, an understated connection existed between astronomical technologies and developments of military interest, such as radar and optical tracking technologies, infrared missile detection and steering, or laser-ignited nuclear fusion, which expressed themselves in technologies from German companies that were eventually integrated into military systems of its NATO allies. Before the 1970s, scientific publications as the output and metric of success in scientific research were only beginning to be discussed in West Germany in this field. Much more salient were the monumentally visible aspects of cosmic research, be they the world's largest telescopes in some wavelengths, and the milestones achieved by ever far-reaching space probes and satellites. By the 1990s, however, the picture had become strikingly different. No new long-term observatories were built again, and a long phase-out began on the existing ones. The profile of newly appointed Max Planck directors went from observatory builders to what today we would recognize as scientific researchers, seeking to organize programs oriented towards specific questions. The actual ownership and operation of the large observatories and space missions had by then almost entirely shifted to multinational organizations like ESA and ESO. The 1990s saw the cancellation or failure of what would have been the next scale of scientific complexes based in now unified Germany. And very few of the most monumental research sites of the multinational organizations are based in the country. This not just in astrophysical research, but also particle physics and fusion research, for example. If built at all, new observatory-like entities were framed as experiments or pathfinders, medium-sized projects with lifespans in the order of a decade, meant not as long-term observational infrastructures, but rather the testing sites for new technologies and techniques to be later deployed in the larger multinational organizations. In the end, these experiments have now lasted for several decades and several even transitioned to become sites of the larger multinational organizations. But the organizational rationale has been firm in its commitment that these facilities should not be called observatories with their implication of long-term permanence. Much has been described on how, in the early 1990s, there was hostility in the astronomical community towards the designation of the upcoming detection devices for gravitational waves or neutrinos as observatories. In our German studies, however, we also see that there is a more generalized difficulty, also in astronomy itself, to the establishment of new entities called observatories, with their implication of very long timescales of existence. The word brought with it an association with previous era observatories with long-standing commitments, operating budgets, and permanent employees, It was a burden at a moment in which flexibility and modular research around short-term collaborations had become the model. And let's not forget that these economic burdens came at the same time as the failure to fund the next generation machine in particle physics, the superconducting supercollider, and the move at NASA towards what were called faster, better, cheaper space missions. Examples were emerging everywhere of the cancellation of next generation flagship projects in favor of what were thought as dynamic, cost-saving alternatives. The model that survives for the large-scale facilities was instead a form of outsourcing to a few global sites that essentially compartmentalized exposure of the scientific users to the economic complexities of their long-term operation. But many claim also create a user clientele that has the illusion of access while the control of the means of scientific production is elsewhere. The model for these facilities had actually emerged in the Cold War era under primarily political considerations, and also occurred first in particle physics, to be taken up later in space research and eventually ground-based astronomy as well. In the United States, Brookhaven in the early 1950s provided the model for the division of facility operations and scientific research, initially as a means to balance the power struggles among many participating universities. Its model was subsequently taken up by organizations such as AURA, the National Radio Astronomical Observatory, and the Space Telescope Science Institute. In Europe, CERN solved a similar problem of the coordination of multinational work while fostering an explicitly political mission of continental integration. And this model then was transferred to the European Space Research Organization and then the European Southern Observatory. Well, facilitated by a centralizing technical necessity, be it a large accelerator, a giant telescope, space mission, or need for a specific geographical site, these organizations were driven by much more than technical constraints. Initially, by the political aims of integrating formerly competing participants, be it universities in the United States or member states in Europe. Then increasingly, as they gained their own experience, in-house expertise and support, and started to amass globally recognized successes, these organizations will increasingly become the model for the operation of long-term scientific projects in general. These facilities emphasize the independence and neutrality of their infrastructural operations, in principle even permitting the access of competing scientific teams for their research. In practice, however, these facilities, while owning the large telescopes and core technologies, also must allow customizations and additions at the level of instrumentation, so that it is at this instrumentation scale that much of the global scientific competition actually takes place. But in contrast to the Cold War era's recognizable brands, this is the site of middle-sized technological companies, often forming part of a complex local ecosystem with a participating research institution, or what is called the Mittelstand of industry in Germany than the large corporations. By the 1990s and 2000s, the deep infrastructural character of this new system resulted in their concentration in very few sites around the world. The scale of economic investment that they represent make their siting decisions battlegrounds between regions and nation states and entire multinational economic blocks. But also, they also have to take into consideration the complex interaction of these global forces with their natural environments and local communities, an interaction that itself becomes transactional and hence commensurate with the economicist ways of framing scientific research. Some instruments from the transitional era happen to adapt very well to this new environment, such as, for example, the middle-sized millimeter wavelength radio telescopes, which provide cost-effective scientific observations on their own, and when combined in 21st century style collaborations, provide significant bonus, such as when tomorrow we see their interferometric combination in another talk. But in these collaborative enterprises, the giant dishes of yesteryear have less of a competitive advantage in a cost-benefit analysis. Given all these aspects, one can see how difficult it is to retrofit an existing Cold War era giant telescope observatory to fit this model of organization. From the scientific labor point of view, they are in the wrong century. Moreover, attempts at their actual technical retrofitting given the hostile socioeconomic conditions and for their long-term survival, may make things worse. One of the reasons for the collapse of the Arecibo telescope's instrumental platform was its overloading with upgrades dating from 1997, precisely in an attempt to make the observatory competitive for the 21st century, while at the same time failing to make the corresponding structural reinforcements for its longer-term operation. It is now evident that these were not seriously planned for further decades-long operations. Thank you.
Thank you very much, Juan-Andres, for your thought-provoking talk. Are there any questions for Juan-Andres? You can stop sharing the screen so I can avoid seeing my face. So there is a question by David Baneke.
Yes, thank you very much. This is all very fascinating and really aligns with lots of things I've been thinking about, especially the separation, as you said, between the instruments and the research, many different backgrounds. I was interested in your comments that smaller instruments and the idea of pathfinder instruments, that they became so popular. Is that related to the fact that for funding perspective and on a political level, you had to argue, I mean, these telescopes or these instruments are all funded as technological innovation and not as scientific research instruments? The increasing, so the different political legitimation.
So what is interesting is that the legitimations of why these medium-sized, say, experiments or pathfinders are funded are varied. So, for example, in GEO 600, that was the reason. It had to be described as technological innovations, but not necessarily. It's not always so directly like that. And in the German case, it fitted more the constraints of having a time scale of 5 to 10 years and a budget of, say, around 20 to 50 million. So this is the scale at which people still, say, controlled the production of something. And upwards from that, it became a more distributed political aspect, supposed to be done by international organizations. But this boundary was a new thing, and this was like an artificial, well, not an artificial, but an understandable change of regime from previous decades, where a single institution had, say the money was not the limiting factor.
Thank you. Looking forward to the book.
Well, if there are no other questions, I will have one. And essentially, I mean, it's the process, the methodology to go to scaling from the German case to the global. I mean, I understand, of course, the global history starting from a local case, that's perfectly fine. But how would you see that, what you see, especially in the first part, I mean, the Cold War era, as the German case characteristics can be easily become a global argument? I mean, if it's global, I must say, it's not completely global, but it concerns a few countries which had the capabilities to do what the West German did, and of course there are not many. So I would like you to make a comment on this. How much this is a global, or in which sense it is a global history?
Yeah, that's exactly what I'm trying to figure out, because I think we do have a very interesting test case with this West German national system, in that, well, on the one hand, it has some very, let's say, specific constraints, especially relating to military technology and let's say a geopolitical need for international integration that is different to say France or the United Kingdom. But at the same time, there's a lot of, I mean, one way of putting it is that there's one complaint often in other countries that the Germans are very imitative. And well, part of the book we treat this more in detail, but it's interesting how global trends reflect themselves on what the Germans do in different periods, and to what degree it's because of direct inspiration that they see what's being done in other countries, and to what degree there's some more like deeper underlying structural system that creates this. So in a way, that's, let's say here I'm opting to explore the deeper structural circumstances of one could build another narrative where you could say, well, the Germans are looking what's happening everywhere and copying it, but we describe in our book how this is not necessarily true.
Thanks a lot, Juan-Andres. So there is a question by Adele, which should be the last one.
Okay, thank you, Juan-Andres, for your very fascinating talk. But there are many things that I would like to know, but I ask you this. Of course, it sounds very provocative that you said, as I understand from your talk, that we are going toward, and we are already in an epoch in which long-term observatories are something that is not anymore timely. So do you really mean this? And of course, we still have observatories, and we're still planning observatories in the future, multi-messenger observatories for the future, which will also use the word observatory, which, as you stated, and I agree, refers to something permanent with permanent employees, something on long-term, large-scale, time-scale observations. You really mean this? And yeah, maybe the cases you refer to are too, in my view, I'm not an expert about this, but in my view, it's not enough to say that this is the trend.
Well, when I look at, well, just how the word is used, let's say, observatory after the mid-1990s and up to the present, it's very interesting that, well, it's really becoming more precisely defined as whatever needs to be long-term, and it's almost like a liability nobody wants to assume. What would be a site with a large instrument or something like that is a facility that has many interlocked modes of operation. Some of the long-term engineering are supposed to be owned, managed by this observatory entity, but sometimes exactly there's an exaggerate emphasis on how the science is supposed to not be done by the same set of people. And it's interesting that it's almost like this rhetoric is excessive compared to the realities of practice at the sites.
Yeah, thank you very much. I thank the speaker